Hello guys, good afternoon. In this video class, I am going to teach you about some theoretical probability distribution. So theoretical probability distribution is what? At first we try to develop the concept about this one. So probability of an event we can calculate by different methods. We can calculate if events are very simple. Suppose if we toss a coin, there is two outputs, head or tail. If we throw a dice, 6 outputs are there. If we drawing a card from deck of card, 52 outcomes are there. These are the very simple events. If we toss a coin 1,000 times, if 2 or more than 2 coins tossed, then what will be the outcomes? It is very difficult to find out the probability. In those cases, we apply probability distribution to find out the probability of an event. So, these theoretical probability distributions are developed for obtaining probability if it is not possible by obtain their probability with the help of simple methods. So these are the theory developed to find out the probability of complex events. I am not going to explain more about this one. Just I am concentrated to your syllabus. For master's level students, 3 theoretical probability distributions are there. Binomial, Poisson's and normal distribution. And for BCA, third semester students also 3 distributions are there. And for other students, that the BBA student, BIM student, also these 3 distributions are included in the course. And the problem based on these 3 distributions, we try to solve, and then for examination point of view also it is very important, and questions frequently asked from this theoretical distribution. Now we discussed on there are 2 types of theoretical probability distribution. Whole distribution we divide into 2 categories. One discrete probability distribution and another continuous probability distribution. Okay, discrete probability distribution and continuous probability distribution. These 2 types of distribution mainly are there. And in our syllabus, there are so many discrete probability distributions, so many continuous probability distributions, but we are concentrated to our syllabus. In discrete probability distribution, only 2 distributions are there. One binomial and another Poisson distribution. Binomial and Poisson distribution, these 2 are the discrete probability distribution. Why these are called discrete probability distribution? Because these distributions are described by discrete variable. There are two kinds of variable, one discrete variable and another continuous variable. Discrete variable consider the value in whole number, but continuous variable consider value between certain range. So discrete probability distributions and continuous probability distributions are categorized by what kinds of variable they considered. Okay, and binomial distribution, Poisson distributions, they are based on discrete variable, so they are known as discrete probability distribution. And normal distribution, that is continuous probability distribution. Normal distribution, that is continuous probability distribution. Okay, and then binomial probability distribution, we just concentrate our class to binomial probability distribution. Actually, binomial probability distribution is a discrete probability distribution, and it is based on, or it represents the outcomes of Bernoulli trial. So Bernoulli trial means that kinds of trial which have dichotomous output. Dichotomous means we can categorize the outcomes of that trial into two categories: occurrence or not occurrence, yes or no, happen or not happen. Like that, we can categorize outcomes of any experiment into two categories, that is known as Bernoulli trial. So binomial distribution represent the outcomes of Bernoulli trial. Okay. Now characteristics of binomial distribution. We discussed the characteristics of binomial distribution. So some characteristics of binomial distribution. Binomial distribution is discrete probability distribution. It is discrete probability distribution, and it represents the results of Bernoulli trial. Second characteristics. Okay, it represents the results of Bernoulli trial. Mean of binomial distribution is NP. N is number of trial, and P is the probability of success. Okay, so mean of binomial distribution is always product of N and P. And variance of binomial distribution is NPQ. Variance is NPQ. N is the probability, number of trial, P is the probability of success, and Q is the probability of failure. So you remember, variance of binomial distribution is this one. So in the case of third characteristics is binomial distribution. In the case of binomial distribution, mean is always greater than variance. Third characteristics, mean is greater than variance. And next characteristics is trials are independent to each other. So one trial, the outcomes of an experiment does not depend upon the trial. So trials are independent to each other. And next one, the probability mass function or mathematical relationship. Okay, mathematical functions of binomial distribution is known as probability mass function. Probability mass functions of binomial distribution of N trial and R success. N trial in R success. That is given by, okay, here P, X is the random variable. X is discrete random variable, and X, when consider the value of R, then we can write that is equal to NCR PR Q N minus R. Here N is you know number of trial. R is the success. Okay, so R always consider integer value 0, 1, 2, 3, 4, 5. Okay, not fraction value. It consider integer value. P is the probability of success. Q is 1 minus P, probability of failure, and in the power n minus R. So here you have that the NCR. So NCR, what is NCR? Okay, so you know that is the combination. Okay, combination. So NCR in mathematics you know the formula n factorial upon r factorial n minus r factorial. Okay, this formula we use. N factorial means we multiply if n is 3, then 3 factorial is 3 into 2 into 1. If r is 2, 2 into 1, like that. So in this way we can calculate this value NCR by using this formula. One problem now we solve. Try to solve one problem. That is, determine the binomial distribution for which mean is 4 and variance is 3. Okay, this problem is given, we have. Determine the binomial distribution. We have to determine binomial distribution which mean is 4 and variance is 3. Mean is 4 and variance is 3. We have to determine the binomial distribution of this one. Here, so for the determination, okay, now we try to solve this one. Here, what is given? At first you write what is given. We have given that here we have you write solution. Okay, solution. We have what is given. Determine the binomial distributions of which mean. Okay, mean is given. Mean of binomial distribution NP. You know, NP is equal to 4. That is given. And variance is 3. Variance is 3 means now variance NPQ. Okay, NPQ this is equal to 3 given. So at first you suppose this one first equation and this one second equation. Now solving first and second equation. Okay, we solve. Now solving first and second equation. Solving first and second equation we solve. So this NP is 4. You put in equation second, the value of NP is 4. Okay, here this NP is 4. So value of NP you put this in second equation. Then 4 into Q is equal to 3. So what is the value of Q? Q is equal to 3 by 4. Q is 3 by 4. Now we put the value, this Q. Okay, Q is 3 by 4. And what is the value of N? Value of Q is 3 by 4. What is the value of P? Value of P, you know, P is equal to 1 minus Q always. 1 minus Q. So our P is equal to 1 minus Q means 3 by 4. P is 1 by 4. P is 1 by 4. Now, what is the value of n? You determine the value of n. Okay? You put the value of P in equation first. Putting the value of putting the value of P in equation first. If you put the value in equation first, then what is in equation first? Equation first is n into P is 1 by 4. 1 by 4 is equal to 4. Okay? N into 1 by 4 is equal to 4. Then what is the value of n? N is equal to what? 16. N is equal to 16. Then x, therefore binomial distribution. Therefore binomial distributions of mean 4 and variance mean 4 and variance is what? Mean 4 and variance mean 4 and variance 3, that is given. Mean 4 and variance 3 is you write x is the random variable, follows binomial distribution b you write, and first one you write the value. First one you write the value number n, okay, 16, and second one you write the value of mean. Always binomial distribution is identified by this. Okay, that is x follows binomial distribution. Always you write n and mean. This is the mean value, and this value is p. Always you write p. P is the probability of success. So if you know the value of n and p, then binomial distribution completely identified, and we can find out different value of the probability of any events. We can easily find out. So binomial distribution is completely identified if n and that the p is known. If n and p is known, then different probability we can easily identify. So in this way, binomial distributions is this one if given information, on the basis of given information. Okay, that's all for today. Thank you.